Hi students, let us discuss the complete named reactions from organic chapters. The 4 organic chapter complete naming reaction we are going to discuss in this session. Are you ready to boost your confidence in the upcoming board exam 2025 chemistry? Ready all? So we have the first reaction from the haloalkane chapter. What is that? Finkelstein reaction. Here we are not just discussing what is the reaction. Let us explain with some examples what's happening there. Ready? So Finkelstein reaction. What is Finkelstein reaction? You have a haloalkane RX. Haloalkane when treated with a sodium iodide NaI in dry acetone medium. Dry acetone. So if they ask you what is Finkelstein reaction, we can say that when haloalkane react with the sodium iodide in dry acetone, Rx contain R plus and X minus. NaI contain Na plus and I minus. So what happened? A double displacement. This NaX go out, right? NaX. And what is the main product? R combined with the iodine, you will get alkyl iodide. Alkyl iodide. So basically, the existing halogen is replaced by iodine. The existing halogen replaced by iodine. That's called what? Finkelstein reaction. So how can you define what is Finkelstein reaction? When a haloalkane react with the sodium iodide in dry acetone, we get alkyl iodide. It is called what? The Finkelstein reaction. For example, ethyl chloride. What is ethyl chloride? CH3CH2Cl. Ethyl chloride to ethyl iodide. You see, the chloride we have to replace by iodide. So that is what Finkelstein. So treat with the sodium iodide in dry acetone medium. In dry acetone medium. So this NaCl out, right? NaCl out. What is left? CH3, CH2I. That is our ethyl iodide. Hope you clear what is Finkelstein. This is a halogen exchanging reaction. You have one more halogen exchanging reaction with you. What is that? Schwarz reaction. This is with the fluorine. Finkelstein is with the iodine. Schwarz is with the fluorine. So one haloalkane when react with the AgF, silver, right? Silver fluoride. Same way, R plus X minus, Ag plus F minus. So AgX out, what is happen? RF. You will get alkyl fluoride, alkyl fluoride. So the existing halogen, if you want to replace by fluorine, we are using which one? Schwarz reaction, AgF. For example, ethyl chloride. What is ethyl chloride? CH3CH2Cl. If you want to make it ethyl fluoride, we want to use AgF, right? AgF, you will get CH3CH2F. And what is the byproduct, my dear? AgCl is the byproduct. Hope you clear what is Finkelstein and Schwarz reaction. Third question. This third question is a very familiar reaction to you. What is Wurtz reaction? Wurtz reaction is to unite two haloalkanes. Wurtz reaction is used to unite or to combine to haloalkane. Let me take one haloalkane that is Rx. Let me take someone same haloalkane that is Rx. And in between, that's we are reacting with the sodium. Sodium in which medium? Dry ether medium. Dry ether medium. What happened, my dear? The sodium take both of the halogen because there are two sodium. Two sodium take both of the halogen. So what out actually? 2 NaX. And what is left in the system? This alkyl and this alkyl join. You will get an alkane, right? Alkane. So what is Wurtz reaction? When two same haloalkanes react with the sodium in dry ether medium, the alkyl group get joined. You will get double number of carbon alkane. For example, methyl chloride. What is methyl chloride? CH3Cl. To ethane. So methyl chloride contain 1 carbon, ethane contain 2 carbon. So if a haloalkane, if you want to double, my dear, use Wurtz reaction. So this is one methyl chloride. This is another methyl chloride. Let me react with the sodium and in presence of the same dry ether medium. What happened? The NaCl out and the CH3 join with the CH3. You get ethane. Plus to NaCl. So what is the purpose of Wurtz reaction, my dear? To combine to haloalkane. Ready? We have another reaction called Fittig reaction. This is to combine to haloarine. Wurtz is to combine to haloalkane. Fittig is to combine to haloarine. For example, let me take it chlorobenzene. Let me take one same chlorobenzene. So it's a reaction between two haloarines. Reacting with what? Sodium. Same thing. That is what? With a dry ether medium. So what is the difference between Wurtz and Fittig? Wurtz is to combine to haloalkane. Fittig is to combine to haloarine. Okay, haloarine. What happens? Reaction same. 2 sodium take both of the chlorine, right? 2 sodium take both of the chlorine. So that is NaCl out. What is left? This phenyl combined with this phenyl. One phenyl combined with another phenyl, plus you will get 2 NaCl. What do you call that? 2 phenyl ring together. That's called biphenyl. Biphenyl or diphenyl. Biphenyl or diphenyl. So always the same product, okay? During Fittig reaction, when 2 haloarines join, you will get phenyl plus phenyl, you will get diphenyl. Example, this one, chlorobenzene to diphenyl, bromobenzene to diphenyl, like that. So a haloarine, if you want to convert into biphenyl, what is the reaction we are using? Fittig reaction. Now, Wurtz and Fittig together, they discovered one reaction that's called Wurtz and Fittig reaction. Wurtz is to combine to haloalkane. Fittig is to combine to haloarine. Then what is Wurtz-Fittig reaction? One haloalkane with one haloarine. For example, let me take one haloarine as chlorobenzene, one haloalkane as methyl chloride. This is a haloarine, this is a haloalkane. Let me react with the 2 sodium. Say medium, dry ether. What happened? Tell me dear. What happened? The NaCl out. The NaCl out. And what is here? One phenyl ring is there and it will combine with the CH3. What is benzene with the CH3 is called toluene. Right? Toluene. So if you want to join a aryl group with a alkyl group, we have to use Wurtz-Fittig reaction. So chlorobenzene to toluene. Chlorobenzene is a haloarine, to which if you want to bring a alkyl group, you say haloalkane. Haloalkane and haloarines combined with the sodium in dry ether, you will get a alkyl group on aryl ring. That's called what? Wurtz-Fittig reaction. Okay, let's go for the next question, dear all. What is Hunsdiecker reaction? What is Hunsdiecker? A simple reaction. Let me take a RCOOAG. What is that? What is RCOOAG? You know, Ag silver, right? Silver salt of a carboxylic acid. Take a silver salt of a carboxylic acid, react with the bromine in presence of CCl for carbon tetrachloride. Simple reaction, dear. 1 Ag combined with 1 Br, you will get a what? AgBr as a byproduct. You will get as a byproduct AgBr plus, can you see there is a carbon dioxide part? Take it out. Carbon dioxide. What is left in the system? Come on. This R combined with the existing Br, you will get RBr. So what is the purpose of Hunsdiecker reaction? To convert a silver salt of a carboxylic acid to alkyl bromide. Alkyl bromide. Only the bromine we can get through this one. So, example, silver propanovate. That means silver salt of propanoic acid. What is the formula? CH3, CH2, COO minus and Ag plus. Silver salt of propanoic acid, when you react with the bromine in presence of CCl4, what happened, my dear? 1 Ag, 1 Br out as AgBr plus the carbon dioxide part is out. Okay, carbon dioxide. What is left in the system? This CH3, CH2 will combine with the Br. You will get ethyl bromide. Ethyl bromide. There will be 1 carbon less in the haloalkane. Okay, here you see 3 carbon, but the product having 1 carbon less. So ready, my dear? So what is Hunsdiecker reaction? Silver salt of a carboxylic acid treated with the bromine Br2 in CCl4 medium, you get a alkyl bromide is called which one? Hunsdiecker reaction. Let's go for the next, a very familiar reaction to you. What is Friedel-Crafts alkylation and what is Friedel-Crafts acylation? What is Friedel-Crafts alkylation? Addition of alkyl group. We are substituting a alkyl group here. Just carefully, simple reaction. For example, you take it as a chlorobenzene, okay, chlorobenzene. You know, halogens is a weak ortho-para directing group, to which let me add CH3Cl, a haloalkane, in presence of N-hydrous AlCl3. Dear all, it's a haloarine, it's a haloalkane. If the medium is dry ether and sodium ether, mean it will undergo Wurtz-based reaction. Careful. But here no sodium and its catalyst is N-hydrous AlCl3. What happened here? The alkyl group. What do you mean by alkylation? Addition of alkyl group. The alkyl group will come as, you know, CH3 plus. Where it goes? It is an ortho-para directing group. So one go to ortho, one go to para. Right? One go to ortho position and one go to which one? Para position. Be careful. So addition of alkyl group on a benzene ring, what you call Friedel-Crafts alkylation. For example, how will you convert benzene to toluene? What is the difference between benzene and toluene? One CH3 we have to bring it on benzene ring, one alkyl group. So add alkyl group. If you want CH3, use CH3Cl in presence of the catalyst what? N-hydrous AlCl3. So Friedel-Crafts alkylation mean addition of a haloalkane to what? In the presence of N-hydrous AlCl3 to a benzene compound. The alkyl group come to the benzene ring. What is Friedel-Crafts acylation? Addition of acyl group. You know, alkyl group means addition of R, alkyl group. But addition of acylation means what? Addition of acyl group, this one. For example, if you consider chlorobenzene again, chlorobenzene is a ortho-para directing group weak. What we are adding here? CH3, CO, Cl, acetyl chloride, ethanoyl chloride, CH3COCl in presence of the catalyst what? N-hydrous AlCl3. See all, this is the acyl group. The acyl group go to ortho and para because chlorine is an ortho-para directing group. You get COCH3 and another chlorobenzene with the what? COCH3. You know, benzene with the COCH3, what we call? Acetophenone. Ready? So this is Friedel-Crafts acylation. Example, benzene, how you can convert it into acetophenone. What is acetophenone? Benzene with the COCH3. So that means if you want to get CH3CO group, that is acyl group. If you want that group, use Friedel-Crafts acylation CH3COCl in presence of N-hydrous AlCl3. So this will come to the benzene ring. So you may think, what happened to the chlorine? Here there is a hydrogen, right? This hydrogen and Cl eliminated as what? HCl from the system. So study what is Friedel-Crafts alkylation and Friedel-Crafts acylation. Next one, what is Dawes process? What is Dawes process? Chlorobenzene to phenol. What is Dawes process, my dear? Chlorobenzene to phenol is called Dawes process. What is the reaction? Can you say? Take chlorobenzene, ready? Chlorobenzene first react with aqueous NaOH at 623 Kelvin and 300 atm pressure. What happened? This H and this Cl, please take it out, my dear. And what is left here? Benzene with the ONA. What do you call this one? Sodium phenoxide. So what is Dawes process? Conversion of chlorobenzene to phenol is called Dawes process. Where take chlorobenzene, first treat with the aqueous NaOH at 623 Kelvin and 300 atm pressure, it becomes sodium phenoxide. When this sodium phenoxide react with the HCl, you know, sodium phenoxide contain Na plus, phenoxide minus. HCl contain H plus and Cl minus. So NaCl out, you get phenol, benzene with OH. This is called what? Dawes process. So conversion of chlorobenzene to phenol by this method is called Dawes process. Ready? Next one, what is Kolb's reaction? Alcohol, phenols and ether chapter. We have three important name reaction, my dear. Coles, Reimer-Tiemann and Williamson. What is Coles? Coles mean phenol to salicylic acid. Coles is only one. Phenol to salicylic acid. What is that? First, we are treating phenol with what? Again, aqueous NaOH. What happened here? That you will get sodium phenoxide, ONA. ONA. What's happening here? This H and this OH water cut, the Na placed there. So that's called what? Sodium phenoxide. Sodium phenoxide first treat with the carbon dioxide followed by acidification. You will get salicylic acid. What is salicylic acid? OH and COOH adjacent. It's called salicylic acid, my dear. Conversion of phenol to salicylic acid is called what? Coles reaction. Same way we have one another reaction, Reimer-Tiemann reaction. What is that? Phenol to a small change is there, salicyl aldehyde. Yes or no? What is the reagent? Same, aqueous NaOH. See all of you? Same like our Coles, aqueous NaOH. But here a small thing we need extra, chloroform. CHCl3. It is noticed that students are writing CH3Cl and all. Don't do the mistake, then complete the reaction. So CHCl3 is called the chloroform. What happened? The upper part becomes sodium phenoxide. To the ortho position, CHCl2 comes. CHCl3 becomes what? CHCl2. Put it on the ortho position. And then we will treat with the NaOH again and second followed by acid. We get salicyl aldehyde. Salicyl aldehyde means OH and CHO. So this is called what? Salicyl aldehyde. Salicyl aldehyde. So Coles and Reimer-Tiemann, don't forget my dear, sure. Next, Williamson ether synthesis. What is Williamson ether synthesis? Take a haloalkane. Ready? Haloalkane. React with NaOR. What is NaOR? Is called sodium alkoxide. So this is a haloalkane. What is this called? Sodium alkoxide. In which medium? Dry ether medium. You know what happens? Simple reaction. This NaX out. You will get ROR plus NaX. What is ROR? Ether. How can you define what is Williamson ether synthesis? When a haloalkane react with a sodium alkoxide, you get a ROR ether. For example, chloromethane. For what is chloromethane? CH3Cl to terbutyl methyl ether. What is terbutyl? You know, carbon connected to 3CH3 group is called terbutyl. This is terbutyl. This is methyl in which an ether. Terbutyl methyl ether. Dear, this part is already there. The haloalkane part already there. So rest of all part is from where? Sodium alkoxide. So let us take it. NaOCCH3 in presence of dry ether. What happened? This NaCl out, this alkyl and this alkoxy group join, you will get the ether. So haloalkane when react with sodium alkoxide, we get an ether called Williamson ether synthesis. Let's go for the next reaction. It is from our chapter aldehydes, ketones and carboxylic acid, Rosenmund reduction. Simple reaction. Take a acid chloride, RCOCl. Study the starting reactant first and reagents. Acid chloride when react with the hydrogen in presence of the catalyst palladium and barium sulfate, right? A poison. So what happened? Acid chloride when react with the hydrogen. Simple. This H, one Cl out as what? HCl. Plus we are using RCO. The remaining H comes here. What is RCHO, my dear? Aldehyde. So what is Rosenmund reduction? A acid chloride when react with hydrogen in presence of palladium and barium sulfate, we get a aldehyde is known as what? Rosenmund reduction. Question. How will you convert benzoyl? What is benzoyl? Benzene with the COCl is called benzoyl chloride. It's an acid chloride. How to convert benzaldehyde? What is benzaldehyde? Benzene with C double bond OH. Overall, what is the conversion here? The Cl you have to make it H. That's nothing but add H2 in presence of palladium and barium sulfate. HCl out, the remaining H comes then. So acid, study what to what? Acid chloride to aldehyde is called what? Rosenmund reduction. For that, which all reagents has to use it. That's it. Next one, Stephen reaction. What is Stephen reaction? They're all cyanide. Cyanide to aldehyde is known as Stephen reaction. So let me tell you what is the reaction. Let me take cyanide first. What is cyanide? RCN. Take your cyanide, treat with SnCl2, tin chloride called stannous chloride, along with what? HCl. What is the reactant and the starting material for Stephen reaction? Take your cyanide, stannous chloride, along with what? HCl. You know what happens? Simple reaction. Add one hydrogen on this carbon, one hydrogen on this nitrogen. It's become RCH double bond NH. Whenever you're taking stannous chloride and HCl, what you have to do there? Add one hydrogen on this carbon and on this nitrogen. So it becomes RCH double bond NH. This compound is called what? Amine. Amine. And this on acid hydrolysis. Acid hydrolysis means what? H2O and H plus. Or you can write H3O plus also. Ready? So H2O contain, two ion. What are they? H plus and OH minus. Correct, my dear? Or you take like this one. H2O contain H2 hydrogen and one oxygen, right? So let me take it simple understanding. From H2O, put this oxygen on this left side, put this H2 on the right side. What it become? RCHO is your aldehyde. What is a byproduct? NH along with the 2 hydrogen, NH3. So conversion of a cyanide to aldehyde by using stannous chloride and HCl is called a what? That's called Stephen reaction. Example, what is ethane nitrile? CH3CN. Ethane nitrile, how we can convert it to ethanol? So basically the cyanide we have to convert into aldehyde, right? Cyanide to aldehyde is what? Stephen. What is Stephen reaction? Use the reagent SnCl2 along with what? HCl. What is this become? CH3, CH double bond, NH. And it is followed by hydrolysis, acid hydrolysis that add oxygen left side, hydrogen right side. It becomes CH3, CHO main product and ammonia as a byproduct. Clear everyone? After Stephen reaction, we are going for Ittard reaction. What is Ittard? Ittard reaction means we can say toluene to benzaldehyde. What is happening there? Toluene to benzaldehyde. Two step, okay? What is toluene? Benzene with a CH3. Benzene with a CH3 called toluene, right? This CH3 we have to make it aldehyde. Yes. First we are treating with the reagent called CrO2Cl2. What is that? It's called chromyl chloride. What is that? Chromyl chloride. CrO2Cl2 called chromyl chloride along with the carbon disulfide CS2. It's form a big complex, my dear. Benzene with CH, okay? Benzene with CH with two things. What is that on that two things? OCrOHCl2. Once again, OCrOHCl2. Or you can write OCrOHCl2 whole twice also. It is a chromium complex, right? Chromium complex. This on acid hydrolysis H3O plus, you get benzaldehyde. This process called what? Ittard reaction. Conversion of toluene to benzaldehyde by using chromyl chloride followed by acid hydrolysis called what? The Ittard reaction. Now we have Gattermann-Koch reaction. You have Gattermann reaction also. This is Gattermann and Koch. This is a direct conversion of what? Benzene to benzaldehyde here. Okay? Benzene to benzaldehyde, what you call? Ittard reaction. Ittard reaction. Benzene to benzaldehyde. What is that? 4 things should be there on the arrow. Like that you remember carbon monoxide, HCl and N-hydrous catalyst are N-hydrous AlCl3 or CuCl. What are the 4 things should be there on the arrow for a Gattermann-Koch reaction? Carbon monoxide, HCl, anhydrous AlCl3 or CuCl, benzene converted to benzaldehyde. Next question, what is Clemmensen reduction? Clemmensen. The reaction is aldehyde or ketone are converted into the corresponding alkane. That's what happening here. For example, RCOR or any aldehyde or ketone you take it. That's treated with zinc amalgam. What is ZnH called? Zinc amalgam and concentrated HCl. Simple. It's a reduction, right? Reduction. So CO make it CH2. That's it. R CH2 R. It's an alkane. What do you have to do in Clemmensen reduction? The CO group make it CH2. So what's that? Removal of oxygen, addition of hydrogen. So it's a reduction. Correct. So for example, how will you convert propan 2-on? Propan 2-on is this one to what? Propane. That is CH3, CH2, CH3. A aldehyde or ketone, if you want to make it alkane, what we can use? Zinc amalgam and HCl can be used. CO become CH2. That's it. What is Wolff-Kishner reduction? Same one, another type of Wolff-Kishner, but it is 2-step. Clemmensen is 1 step, Wolff-Kishner is 2 step, but process is the product is same. Okay. For example, let us take a aldehyde or ketone. So RCOR, let me take it. First, we are treating with what? NH2 single bond NH2. What is NH2? NH2 called, my dear? Come on, come on. What is NH2? NH2 is called hydrazine. Hydrazine, when you treated any one of the H2 and oxygen, goodbye. H2O, goodbye. What do you get? R, C, R, double bond, N, NH2. You get hydrazone. Hydrazine reacted product, what we call? Hydrazone. Next, we will treat with ethylene glycol. Ethylene glycol, KOH and heat. Ethylene glycol and KOH will get heat. So what happened? Simple. Just this NN, take it out. What is NN? Nitrogen gas. What is left? The H2 add on this carbon. You get R, CH2, R. That's again alkane. So conversion of aldehyde or ketone to their hydrocarbon is called what? Clemmensen, Wolff-Kishner. Clemmensen is 1-step process. Wolff-Kishner is 2-step process. Ready, my dear? Example. How will you convert propanol? What is propanol? CH3CO CH3 to what? Propanol to propane. Either we can use which one? Clemmensen reduction or Wolff-Kishner. Okay. If they ask you through Wolff-Kishner, what you have to treat first with? First, we are treating with the hydrazine. Second, we are treating with what? Ethylene glycol. Ethylene glycol, KOH and heat, that we have to use it. Ready? So purpose of Clemmensen and Wolff-Kishner is same but 2 different reaction. Next one, aldol condensation. What is aldol condensation? Important one of the reaction, aldol. Aldol condensation mean in order to undergo aldol condensation, alpha hydrogen must be there in the compound and the alkali should be dilute alkali. So alpha hydrogen should be there and dilute alkali we are using, dilute NaOH or dilute KOH. For example, let me take one ethanol, ethanol, CH3CHO is ethanol, right? So aldol condensation mean it is a reaction between 2 same species. And what is the reagent we are using? Dilute NaOH, dilute NaOH. Carefully listen, my dear. So this is the aldehyde functional group. So this is the alpha carbon. Yes, it contains alpha hydrogen. This is so. What is mean by alpha carbon and alpha hydrogen? The main functional group connected carbon is called alpha carbon. Alpha carbon contain hydrogens are alpha hydrogen. Ready? I'll give a short method to do aldol condensation. Carefully listen. From the second compound, take one alpha hydrogen. From the second compound, take one alpha hydrogen and give to the oxygen of the first. Can you repeat? From the second compound, take one alpha hydrogen and give to the oxygen of the first. Ready? So O become what? OH. And connect from where you lose hydrogen, this carbon connected to the oxygen connected carbon. Can you say the product, all of you? CH3, CH, the O become OH. What is left here? CH2 and then we have CHO. And have you seen this compound contain aldehyde and alcohol together, therefore it is called as what? Aldol, right? Therefore it's called aldol. But what is the process called? Aldol condensation. Condensation, removal of water. For that you have to heat the aldol. What is dehydration mean? OH and H. OH I am taking from this one, hydrogen I am taking from this one. So you will get a double bond between alpha beta. You get a ene, right? You will get a enol. This is called aldol condensation. When aldehydes or ketone with the alpha hydrogen react with the dilute alkali, this first form aldol. Once you heat, it undergo dehydration. You will get the final product. And what do you mean by cross aldol condensation? Same. Alpha hydrogen should be there, dilute alkali should be there, but cross aldol mean here the reaction is between two different species. Aldol mean two same species are reacting, cross aldol mean two different species are reacting. For example, let me take CH3COH plus CH3COCH3. Here I am taking ethanol and propanol. Ethanol and propanol. So if you taken two different compound and they contain alpha hydrogen, these all are alpha hydrogen, right? Are you clear what is alpha hydrogen, my dear? Main functional group connected carbon is called alpha. Alpha carbon contain hydrogens are alpha hydrogen, ready? So if you use ethanol, so let me take it as A compound, propanol, let me take it as B compound. When you react with a dilute alkali, you may get 4 products. How we get 4 products? There are 4 combinations are possible. 4 combinations, can you say how it is actually? The A combined with another A. A combined with another A. So one ethanol can react with another ethanol. So let me take it. And how to write a simple manner, how we can write the product is very careful. The first ethanol, so AA, you will get 4 combination. How it is, I'll tell you. This is AA combination and a BB combination. Then you have a chance AB combination. Then we have a BA combination. Means one ethanol react with another ethanol, one propanol react with another propanol, one ethanol react with a propanol, one propanol can react with ethanol. So 4 products can be formed. 4 products. I'll tell you how to write the 4 product in a simple manner, my dear. AA means ethanol combined with one more ethanol, right? So first ethanol, the 2 alpha hydrogen write down. So I'm writing this one as CHHH, then CHO. See all of you? First ethanol molecule, 2 alpha hydrogens I am writing down. 2 alpha hydrogens I am writing down. Ready? And the second ethanol I am writing below as normal. Ready? What we are treating first with what? Dilute NaOH. Finally, we will heat, right? We can directly write the product, okay? Simple all, just cut the H2O. For that, to cut H2O, I told you to write like that. First compound, 2 alpha hydrogen write down. Second compound, the oxygen write up. And just cut the H2O. Can you just join them? I'm starting from here, okay? I'm starting from here. So the product is CH3, CH and double bond. Where is the double bond? This double bond, okay? This double bond connected here. CH and that it's connected to what? CHO. Ready? Same way, let me give you the example for B plus B. So it means one propanol you are mixing with another propanol. So this propanol, it's 2 alpha hydrogen. Let me write down. And what is left here? COCH3. The second compound I'm writing CH3, COCH3. Okay. So first we are treating with what? First we are treating with dilute NaOH. Second we are heating the compound. So H2O cut. What is left? I'm starting from here. CH3, CCH3, double bond, CH, single bond, COCH3. I hope you can complete the remaining 2. So when you're doing cross aldol condensation, it is the reaction between 2 different species. If both of them contain alpha hydrogen, 4 products like that, you can get it. How to write the product, my dear? First compound, 2 alpha hydrogen, write down. second compound, the oxygen right up, just cut the double bond, the water, and just join them. Ready? Now we have Cannizzaro reaction. Cannizzaro reaction is just opposite condition of aldol and cross aldol. There should not be any alpha hydrogen in the compound. No alpha hydrogen in the compound, and concentrated alkali we are using. Concentrated NaOH or concentrated KOH. Example. Let me take a methanol. What is methanol? HCHO. Let me combine one methanol with another methanol. See, this is the functional group here. Nearest of this functional group, is there any carbon? No alpha carbon, so no alpha hydrogen. Okay, so and it is reacting with a concentrated NaOH. Now listen very carefully, my dear, how to write the product here. Simple, very simple. First compound, what is that? Methanol. Methanol that you make into corresponding alcohol. What is methanol corresponding alcohol? Methanol plus. Or you think like this one. First CHO make it CH2OH. Do this one. Very simple. First CHO make it CH2OH, alcohol. What is CH2 plus this H? CH3, that is CH3OH. Second compound CHO make it COOH, acid. Acid, okay. First compound CHO make it alcohol, second compound aldehyde make it acid. But it won't exist as the acid, you know, as the Na, sodium metal is there. So sodium displays this hydrogen, so it becomes COONA. So what is left here? HCOONA. So what is happening in Cannizzaro reaction? One compound convert to corresponding alcohol, second compound convert into corresponding acid, sodium or potassium salt. Let me give you another example. Benzaldehyde is an aldehyde which do not contain any alpha hydrogen. So benzaldehyde plus benzaldehyde, I am using concentrated KOH. Listen very carefully, my dear, carefully. First compound, I told you CHO make it what? CH2OH. So what is the product? Benzene with CH2OH plus second compound convert the CHO into what? Acid, right? But acid won't be there. That potassium or sodium that will displace. Here potassium, so that becomes what? Benzene with the COOK, potassium benzoate. So one compound correspond to alcohol, one compound correspond to acid, sodium or potassium. So that's called what? Cannizzaro reaction. Now we have the very important reaction. One is in acid part, HVZ, right? What is the reaction called? HVZ, the reaction Hell-Volhard-Zelinsky reaction. Here also condition alpha hydrogen must be there in the acid. This is acid reaction. Okay, HVZ is given by acid. For example, let me take ethanoic acid. Is this ethanoic acid contain alpha hydrogen? Yes. This is the functional group. So this is the alpha carbon. Yes, it contains hydrogen. Let me react with any of the halogen in presence of red phosphorus, followed by hydrolysis. You know, any halogen actually not possible here. The X2 can be chlorine or bromine. Okay, only chlorine and bromine through this HVZ. So all of you, if a acid contain alpha hydrogen, treat with the chlorine or bromine with a red phosphorus followed by hydrolysis. Simple. Process is simple in HVZ. Remove one alpha hydrogen. Place the halogen. So it becomes CH2 X and COOH. See all of you carefully here. You know this carbon is called alpha. So here alpha carbon carry halogen. So it's called what? Alpha halo carboxylic acid. Alpha position there is a halogen. So all of you, when an acid contain alpha hydrogen react with the halogen in red phosphorus and water followed by hydrolysis, remove one alpha hydrogen, place the halogen. Finish. I'll give you one example. Propanoic acid. What is propanoic acid? CH3, CH2, COOH. Propanoic acid you have to convert into 2-bromo-propanoic acid. See what is the change here? What is the change here? Have you noticed? This is the alpha carbon. From this alpha carbon, one alpha hydrogen we losing and we are bringing one bromine. For that, what you have to use there? Br2 with red phosphorus catalyst followed by hydrolysis. That's it. Clear? So removal of one alpha hydrogen, placement of the halogen called what? The HVZ reaction. Now we have Hofmann bromamide degradation reaction from the chapter amine, last chapter. What is Hofmann? Take an amide. Okay, starting is what? Amide. See, Hofmann bromamide. What is the meaning of bromamide? Bromine and amide is there. Bromine and amide is there. Okay, so amide is ready, bromine is ready, and the reaction is carried out in a base NaOH and heat. Okay, my dear. What are the starting compounds of Hofmann bromamide? Amide, bromine, and the NaOH. Very simple. Cut the CO group from the amide. Cut the CO group. What is left here? RNH2. You will get a primary amine, right? Plus the byproduct, keep in mind all of you, if the base is NaOH, always byproduct is same. Na combined with the Br, you will get NaBr. The another that's not balanced actually, then again Na will combine with the CO part and all, it will become Na2CO3 along with the water. So what are the byproduct in Hofmann reaction dear? Na or NaBr will be there, Na2CO3 will be there, H2O will be there if the base is what? NaOH. So when amide react with the bromine and the NaOH, what's actually happening there? What is the speciality of Hofmann bromamide? Degradation. Why it's called a degradation? One carbon always less in the product. I'll show you one example. Benzamide. What is benzamide? Benzene with the CONH2 is called benzamide. You have to convert this benzamide into what? Aniline. Aniline. Take it all of you. Aniline. What is the difference here? Overall, you have to cut the CO group. Yes or no? Overall, you have to cut the CO group from the amide. So use what? Br2 and NaOH, right? Br2 and NaOH. This CO group cut, that's it. Why it is called a degradation? Because one carbon less in the product. See, this carbon already gone, right? So if you start with the propanamide, you will get ethanamide. If you start with the butanamide, you will get propanamide. Like that, if the product contain always one carbon less amine. Okay, that's called Hofmann bromamide degradation. Next we have Gabriel-Thalamide synthesis. It's one of the preparation of amine. Gabriel. What is thalamide? Thalamide is benzene with CO, N minus and H plus. And when you're writing as ion, we can say N minus and what? H plus. NH. This is called thalamide. Okay, this is called starting material is called thalamide. Thalamide. First we treat thalamide with which one? You know, alcoholic KOH. What happened? Alcoholic KOH if there K plus is there, OH minus is there. This H plus and OH cut, the potassium come to the chain. So it become benzene with CO, N minus and K plus. What it is called? Potassium. It's called what? Potassium salt of thalamide. Potassium salt of thalamide. So what we are doing first, my dear? The thalamide, first we are treating with the KOH, and what happened? The potassium come to the chain, it's called potassium thalamide. Then we are treating with the RX. What is RX? Haloalkane. Haloalkane. RX contain R plus and X minus. So this KX will go out. You get benzene with the CO, N minus and R plus. It is called N-alkyl thalamide. N-alkyl thalamide. On nitrogen there is an alkyl group. N-alkyl thalamide. And final step, let me write like this, okay? Final step, I'll give a shortcut method. Use 2NaOH. 2NaOH. Normally, how you take the ions of NaOH? Na plus and OH minus. This time I am taking H plus and ONA minus. Just for understanding, okay? So cut the this part, CN bond. Cut the CN part. What do you have what do you have right side? Rn, right? To the Rn, can you see 2 hydrogen here? To the 2 hydrogen add on the nitrogen. So what you will get? RNH2. It's a primary amine. What is a byproduct, all of you? Benzene with CO already there, CO already there. To the CO and CO, the ONA get attacked. ONA and ONA. So what is Gabriel thalamide synthesis, my dear? First take thalamide, treated with alcoholic KOH, it becomes potassium salt. This potassium salt thalamide treated with a haloalkane, the alkyl group comes, that's called N-alkyl thalamide. That's when you treated with the NaOH, the bond break, you will get amine as a main product. Now, what is carbylamine reaction is also known as isocyanide reaction. Isocyanide test or isocyanide reaction. What is that? Take a amine, for example, RNH2. It is only possible with the primary amine, okay? Primary aliphatic or primary aromatic amine, we can use it. Which is treated with the chloroform. What is chloroform? CHCl3 along with the alcoholic KOH and heat. So what are the starting material of carbylamine reaction? The amine, which amine either primary aliphatic or primary aromatic. That we are treating with the what? Chloroform and alcoholic KOH. You know what happened? The NH2 become NC. That become RNC. What is NC is called? Isocyanide. Isocyanide, and it's having a foul smell. You may study it as a distinction test. And what are the byproduct is important? This K combined with the Cl, you get KCl along with the H2O. So how you define what is carbylamine or isocyanide reaction? When a primary amine react with chloroform and alcoholic KOH, you get isocyanide. For example, I have aniline, okay, aniline. Is it a primary aromatic amine? Yes. Treat with the chloroform CHCl3 along with the alcoholic KOH. What happened, my dear? NH2 become NC. NH2 become NC, phenyl isocyanide along with the what? KCl and H2O. So NH2 become isocyanide. Ready. Next one, diazotization reaction. What is diazotization? Aniline. We'll take aniline. Aniline when react with NaNO2 and HCl. NaNO2. What is NaNO2 called? Sodium nitrite and HCl at 0 to 5 degrees Celsius. You may note that NaNO2 and HCl also written as what? HNO2, nitrous acid. Because NaNO2 and HCl when react, what you get? NaCl and HNO2. So HNO2 also we can express instead of this. Ready? What NH2 become? NH2 converted to N2 plus Cl minus. What it is called? Benzene diazonium. Benzene diazonium chloride. Ready, my dear? Benzene diazonium chloride. So conversion of aniline to benzene diazonium chloride by treating with the NaNO2 and HCl at 0 to 5 degrees Celsius. What you call? The diazotization. From that, you may study this reaction. What is Sand-Meyer's reaction? The formed diazonium salt. This formed diazonium salt, what is diazonium salt? N2Cl. You can convert it into different products. For example, if you are using Cu2Cl2, if you are using Cu2Cl2 or HCl, Cu2Cl2. Instead of Cu2Cl2, sometimes you can see in the papers like CuCl also. Okay, same one. Copper is in one oxidation state. So when benzene diazonium chloride react with the Cu2Cl2 or CuCl, that Cl, we get chlorobenzene. What is the halogen here? Chlorobenzene. Along with this nitrogen gas come out. Nitrogen gas come out and the chloride ion also come out. Anyway, benzene diazonium chloride when react with the CuCl or Cu2Cl2 with HCl, we get chlorobenzene as a product called Sand-Meyer. Same way we can use CuBr or HBr. Then who will come? Bromine come to the place, that's called bromobenzene along with the nitrogen. Okay, and this Cl minus also will be there. This is enough. So diazonium, so conversion of benzene diazonium chloride to chlorobenzene or bromobenzene by treating with the CuCl and the CuBr respectively known as what? Sand-Meyer reaction. Same way, we have an alternate method for that, Gattermann reaction. What is Gattermann reaction? Benzene diazonium chloride, when react with, here this time we are just changing the catalyst, my dear, just changing the catalyst. What is the catalyst we are using? Copper powder with HCl or copper powder with HBr. Copper powder with HCl or copper powder with HBr. So here who will come? The chlorine come to benzene. Chlorine come to benzene, and this H and Cl will be HCl, and the nitrogen gas come out. Here what is the halogen? We have bromine. So bromine come to benzene ring, and this H combined with the Cl, HCl, along with which gas? Nitrogen gas. So what is the difference between Sandmeyer and Gattermann? In Sandmeyer, we are using benzene diazonium chloride with a CuCl or CuBr. Here we are using copper powder with HCl or copper powder with HBr, but products are similar. And Wurtz-Tiemann reaction, what is that? First take your benzene diazonium chloride N2Cl, okay, benzene diazonium chloride. First I am treating with an acid called HbFO4. You know what is the name of HbFO4, my dear? Fluoroboric acid. Not at all. Fluoroboric acid. It contains H plus and BFO4 minus ion. First step, this H and Cl out as HCl. What is left in the system? Benzene with N2 plus BFO4 minus. Ready all? This salt when heated, directly heat. This salt when you heated, you know what happened? Among the 4 fluorine, 1 fluorine place it on benzene. So what do you get? As a product, you get fluorobenzene. And this fluorobenzene we added, what is left in the system? Nitrogen gas. And what is left here? BF3. That is called our Wurtz-Tiemann reaction. So benzene diazonium chloride, when react with the fluoroboric acid, first you get this salt. Once you directly heat, 1 fluorine come to benzene, you get the product as fluorobenzene. So through Sandmeyer and Gattermann, we can prepare only chlorobenzene and bromobenzene. But Wurtz-Tiemann is used to prepare which one? Fluorobenzene. And we are going for the last and final reaction, name reaction. Coupling reaction. Here we studied in the last part of the amine chapter. So let me take benzene. 2 coupling reactions are there. I am taking benzene diazonium salt. Okay. Is it benzene diazonium salt? Benzene with the N2 plus Cl minus. Benzene diazonium chloride. First I am going to treat it with what? Phenol. Phenol. What is phenol? Benzene with OH, right? Benzene with OH. Ready? You know, phenol is acidic one. So we are using a basic medium here. And before going to the product, let me tell you the second reaction also. And take a benzene diazonium chloride. Okay, benzene diazonium chloride. This time I am treating with aniline. Aniline. First is with which one? Phenol. Second is with which one? Aniline. Since aniline is basic one, we are using an acidic medium. Okay, ready? 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 And how to write the product? Very carefully listen, my dear. Very simple. This is our benzene diazonium chloride with the phenol. This is benzene diazonium chloride with which what? Aniline. From the para position, take 1 hydrogen. From the para position of phenol, take 1 hydrogen. From para position of aniline, take 1 hydrogen. You know why? This H and Cl is going to eliminate. So what do you get the product, my dear? You will get benzene, okay, and the triple bond become double bond, N double bond N, and another benzene on which what you have? OH. Similarly, what you get? Here benzene and N double bond N, another benzene, and here what you have? NH2 group. Ready? This product name is important here. This is called what? Para hydroxy. Para position hydroxy, and this entire group is called azobenzene. Para hydroxy azobenzene. You may study color orange dye and all it form, right? Similarly, this is para amino. This is called a para amino azobenzene, yellow colored dye and all. So this is called a what reaction? Azo dye formation. These all are coloring agent. Orange dye, yellow dye, like that you can prepare. So coupling reaction is also called what? Azo dye test. Preparation of what? Dye formation, coloring agents. So benzene diazonium chloride, when react with the phenol and aniline, it undergo coupling reaction, you get dyes. So these are the complete naming reaction in the chapter Organic Chemistry. Make more confident in organic chapter, because out of 70, around 33 mark for your organic chapter. So conversion question series, around 120 conversion series already we completed. This is the organic chemistry complete naming reaction. In a stretch you can practice with the example. Go for your examination in 2025, 70 out of 70 anyway we have to score it in chemistry exam. Wish you all the very best. Keep practice.